So hello, my name is Vincent Castaneda, and I'm here to convince you that you should be using awk in some capacity, like right now. So first off, a little bit about me. I'm from San Francisco. I work at a company called Flyer, so if you've seen those little stickers with like the cute dogs in an airplane, I brought those. We're actually not recruiting, so I literally just brought like cute swag from my company. No ulterior motive at all. And I think I actually have the record for longest travel time to this conference, not because I live in San Francisco, but because my wife and I are coming back from a trip to Japan. So we traveled from Okinawa all the way to Toronto in like one stretch of 23 hours. So I'm still very heavily jet lagged, and to compile on that, I've just been alerted that there's a prod issue happening at my company. So if I'm a little jittery, there's like two reasons. One, I'm giving a talk, and two, production is on fire. But it's okay, we have really like smart people at my company solving it right now. It's all good. And the most important is, here's my dog. So we have office dogs at our company, and so this is the Shiba Inu. Her name is Charm, she's 8 years old. Okay, now on to the much less important part of the rest of the talk. So we all have a problem no matter what part of computer science that we're coming from. It's common across all of us, whether we realize it or not. It's data. We want it, we need it, and it's really hard to extract from like the raw data sources sometimes. So, but that's okay, because our computer science predecessors have given us tools to make this problem not so difficult. So what is the solution? It's regular expressions, of course, regular expressions. You know, it's everyone's favorite go-to solution that usually results in a second really large problem. But not this time, because we are going to bend regular expressions to our will using awk. So, what is awk? Awk is a text processing language. It is a simple language meant for quick data processing, and it grew out from the desire to expand the command line tool grep. In fact, like the same person who like made grep like helped develop awk. And it comes standard with like most Unix systems today. So if you open up your laptop, if it's a Mac or a Linux-based, Unix-based laptop, it's like pre-installed already. You can already use it. You don't have to install anything most of the time. And it's designed so that like common, not too tech-savvy individuals can use this. So if you're like in the humanities and you have like data that you found, but you're not sure how to like gain the most use out of it, you can quickly process it using awk, using like very short programs. So, so who done it? So these are the individuals that like developed awk, Weinberger and Kernighan. These are like 3 Bell Labs rock stars, and they developed awk in the 70s. If you're unfamiliar with like what Bell Labs is, it's a research institution that was like originally in New York and it might have other places now. But like this lab like created some of the like foundation for all of computing we know today. It's like very wide-reaching, has been around since like literally like the 19th century. And they made things such as like transistors, lasers, the Unix operating system, C, C++, underlying technologies for cell phones, the internet, solar panels, etc. They're pretty amazing. You can like see all the different people who came out of the Bell Labs who like won Nobel Prizes and all like that. So good stuff, but wait. Hey, it's awk, hey. Okay, yeah, so. In case you didn't know, it's not some fancy, like, what do these letters mean? It's like just their names concatenated. And like in an interview with Aho, he actually explains that like other researchers walking by their office when they were working, like would go like, awk, 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 to like kind of make fun of them. But it's okay, because they liked it so much that they actually made it into the name of the language they were developing. Okay, so now we kind of know that awk is like the simple processing language, and we have a little bit of extra information about like the who and the why, and so now we can ask like, when would I actually use this language? So well, we want to use the language when we have like a ton of text data. That's what it's really good at. Whether it's books, CSV files, other things, and we need to like quickly extract information from them. And that's it. Don't use it for like anything else. You can. I think like there are people who've made some like really complex like architecture in awk, and like they brought it to like Aho and like, hey, check this thing out I did in like awk, and he like freaked out. It's like, why? Don't do it. Like so, yeah. If your program is like approaching 10 lines long, awk is not the language to use. So the core functionality of awk is based around these two kind of components, a pattern that we're like matching across, and an action to perform once you have validated that pattern. And it does these patterns matching on records. And so the most like common record is a single line of text. So if you think of like a book or a file, every single line is a record. And within the records, you have fields. And these fields are usually what we call words. So just very simple kind of what are records and fields. I may or may not continue to use those terms depending on whether I remember them or not. So let's build a simple awk program in the command line and see what it looks like. So first we need to invoke awk, then we can write a program, and then we can specify the input that we give to the program to process. So what would this look like? So here's the command line. We say awk, and then we write the entire program, and then we give it the input. In this case, the book Dracula. And that's it. And you might notice that we are kind of missing the action part of the pattern action matching, but it's OK. Awk has our back. The default action is just print $0, and that means just print the line or print the entire record. And the default input, if we don't give it like a text file, is just whatever we type into the command line and hit enter. It'll attempt to match the pattern. If it works, it'll just print the line. So before we dig a little bit into like the live programming, which always goes perfectly well 100% of the time, we can see some of like the built-in variables that awk gives us for free. So $0 is like the entire record. $1 is the first element or field of that record. So it'd be, in most cases, like the first word of every single line. And then you can expand this to the nth word. There is a beginning keyword where like any pre-processing before we start pattern matching, we can put in this like begin bracket. Same with post-processing. And the FS is a special field separator. So if we don't care about splitting on spaces, we can split on like commas if we're like doing CSV files and things like that. We can even like split on new lines if we have like groups of 3 and then a blank line. And so you can actually like, each field can actually be a full line, and it gets confusing. You can do whatever you want with it. So like very, very simple programs are like awk print. This will just print the first word of every single line. Here we are switching the delimiter, whatever words are hard, to a comma instead of a space. And we want to keep in mind that if you're doing this on the command line, you do Control-D, and then that signals the end of file. You don't want to do Control-C to like get out of the file, because then you'll skip any post-processing you're doing, and you might not want to do that. So let's start with some practical examples. So we're going to switch over to our command line. Can we all see this? I'll make it a little bit bigger. Great. So we can look at kind of where we are. We have this awk script that I wrote that we'll get back to later. We have Dracula.txt, and we have this veggieprices.csv, which I'll also get to in a little bit. And we can very quickly just like do that Dracula example that we saw. So we just write awk, and then we write the entire program, and then we tell it to run on Dracula. So there we go. So here's every single line in the book Dracula that contains the word Dracula. And as you can see, it's not like a super strict. The Dracula was like a regular expression, and it's a very loose regular expression. So it doesn't need to be like only the word Dracula. You can see like Draculas, apostrophe S shows up a lot, and it's all fine. But OK, that's kind of like a little bit interesting, but we can make this a little bit more complicated and say like, hey, what if we want to see like how many times is Dracula or Dracula's castle, or just is Dracula referenced at all within the entire book? And we can even see that this is going to be inflated slightly, because like at the very end we have like Project Gutenberg, Book of Dracula. That wasn't in like the original story. It's just like saying where this text file came from, but yeah, whatever, who cares? So if I have my notes to make sure I actually write the correct program. So we want to set up a little bit of post-processing. We want to do pre-processing, we want to do post-processing. So we can write a conditional statement that says, if, and then we can add our regular expression, and we'll just say we don't care if it's capital or not. If Dracula, and then we're going to increment a counter by 1. And then at the end of everything, we're just going to print count. And then pass, oh, thank you. Feel like I'm like shaking because of so many things right now. I love it. All right, so hopefully this works. There we go. Oh. That is not correct. let's see. Let's see what I did incorrectly here. See, always goes perfectly well, 100% of the time. Oh, yes, I have some bracket mismatching. So if I go here, I think that'll work. Nope. All right. Yeah, I think I hear the correct solution. We're going to cheat and copy and paste the correct command line just so I'm like moving forward. Yeah, I did some like funky things with the brackets. Holy crap, this is going well. I'm just going to skip over this. The answer is actually 36. So even with like the extra titles and in credits and everything like that, like Dracula only shows up 36 times in his own book. So, you know, that's kind of silly for him. But let's take another example. And I'm moving on in the interest of time because even though I'm pretty sure you had the correct answer, I'm like too jittery to figure this out. So this is like a series of veggie and fruit purchases in like a specific city in India that I found off of like a free website. And I love potatoes. So I want to know potato prices. So what does that actually look like? So here we go. We can go back to here, and we can see that we have these veggie prices. So if we look at the veggie prices, we have a CSV file that's like this massive, like null. It's got dirty data. It's got a lot of weird stuff going on. So let's write a quick program that we did before to look at all of the potatoes. Here they all are. Great. But as I mentioned before, like, oh no, we got like some like bad data in here. Like we got 0 prices, like maybe someone like bartered and they didn't actually record a price, or we got like null value somewhere else. So let's like use awk to see if we can like make this a little bit cleaner. So what we need to do is we actually need to go back up here and we need to say, hey, there's actually some, we need to do a little bit of like pre-processing on our data. So one, we need to switch the file separator, as you mentioned before, to a comma, because we're working with a comma delimiter file, a CSV file. We don't want to break on the spaces because like there's an inconsistent number of spaces between all the different files. So we can say, and I'm going to like follow my notes super closely, make sure they work. If, and this time we're going to do this right. So if we want to look for potatoes, and we can put in our own logic into like awk, just like most other languages, the 4th word is greater than 0. And so here we like, sorry, indexing doesn't start at 0. It starts at 1 for words. Like, I know this is like a sin in a lot of different languages, but you know, we'll trust awk. So we got 1, 2, 3, 4. The last column is like the price is an integer. There we go. And we also want to clean up a little bit more and say it doesn't equal null. And then at the very end, we're going to give it the command of print 0 on veggie prices. So there we go. So now we have like every single like potato-related transaction happening, and the price, and when it happened, and it's like the data is clean because I magically cleaned it up based on my own arbitrary rules of what I want the data to look like. And I can take this entire thing and I can like put it into like my fave veggies .csv file. Boom. That's so amazing. So now I like took this like 50 some odd megabyte like CSV file and I parsed it down into like only the data that is relevant to me in like a single line of awk code. So yeah, that's like pretty cool. Yeah. So then what we can do, I'm like a little bit over time, so I'll go like pretty quick. Slightly less practical example, and this is really funny because we were like talking about this in like the Hadoop, like MapReduce and everything like that, and I think there's some other like things. Is I wanted to know word frequencies and volume of text, and so we can compare languages. And so if we look at C, we have like, this was the solution that I found for C. I tried to reteach myself C over like the course of 2 days, and I gave up, and I didn't think it was worth it. And so I like piecemealed this together from like some Stack Overflow stuff. It's about 60 lines of code. If we look at Java, which I did write, haha, it's also about 60 lines of code. But both of these have like third-party packages, and they're kind of gross. And this took me an evening to write, you know, casually. And then we look at Python, and OK, now we're kind of getting somewhere. I work professionally with Python daily, so it only took me like 3 Stack Overflow references to like come to this in a couple of minutes. And I even like, hey, this is pretty clean. It's only 25 lines. And I like kind of threw in a sort at the end to make it alphabetical. So that's pretty cool. And so now we have awk. There it is. This is the entire program to count word frequencies in any given file that you give it. And NF here is like the number of fields variable. It's like a built-in variable. So you don't even have to count how many words there are in a line. You just like cycle through however many they are, because awk tells you how many there are in every single record. So I lied a little bit as well. This is the actual awk program I ran to do that, but I like did a lot of other extra pre-processing here. I got rid of ugly punctuation. I made everything lowercase, and I handled some other things with bad punctuation and weird words. And even if I expand that out into the same kind of representation as the other languages, it's 12 lines long, and it's really readable, except for the regular expressions inside of them, but we will not speak ill of regular expressions during this talk. So, and of course, if we want to, we can actually save this in TXT file. I won't run it because I'm over time already. But we can just, we can invoke these patterns via a text file, such as any other program. So that's it. Thank you. You can't really find me on Twitter. Yeah, but you should follow my wife. She's really great. So thank you.